Example 4.2, the effects of a gasoline tax. Before explaining this, I'd like to explain this one again. So we studied normal good case, given good case, inferior good case when price of food decrease. Then now think about what happens when price of food increase. Price of food increase. Then slope, P4, PC increase. Right? Then demand for food decrease, so negative. And clothing consumption increase, positive like this. And what happened in income? Price of one good increase. The consumers' purchasing power should decline. So this one decline, right? When relative price constant, then what happened? Income decrease, food consumption decrease. So usually this one decrease, this one decrease. Negative, negative. That is normal good case. Okay? So in the exam, sometimes I'd like to draw this kind of setup in the answers here, right? So also think about example 4.2. Effects of gasoline tax with a rebate. A gasoline tax is imposed when the consumer is initially purchasing 1,200 gallons of gasoline at point C. So original equilibrium condition happen here at point C. After the tax takes effect, so tax imposed, the price of that good increase, right? So price of that good increase. Then new budget constraint rotates like this from here to here. New budget constraint after tax, right? Then consumer solve utility maximization problem again here. Then finally new solution occurred at point E. Price of food or what is this? Here, gasoline. Gasoline increase, then gasoline consumption decrease here to here, C to E. This one, this amount. Okay? That is explained here. However, when the process of the tax are debated, right? The effects of tax rebate is very similar to increasing your income. Increasing your income. So your income increase from here to here like this. Right? His consumption increase amount to new equilibrium point is near here, point H, for example, here. So you can draw a new utility curve like this. Right? Despite the rebate program, the consumer's gasoline consumption has fallen, as has his level of satisfaction compared to point C. Okay? Next slide. Market demand curve. What is market demand curve? Curve relating the quantitative good that all consumers in the market will purchase to its price. Right? Price is $1, $2, $3, $4, $50. We can solve utility maximization of individual A, then optimal consumption is like this. Also, individual B's optimal consumption is this. Individual schedule, consumption schedule of A, B, C. And market consists of three consumers. Then market demand is summation of each individual demand at the same price. So price is $1, 6 plus 10 plus 16. When the market price is $2, then this one plus this one plus this one like this. Can you understand? So market demand curve is summation of individual curve at the same price. Okay? So individual A's demand curve, individual B's demand curve, individual C's demand curve. And market demand curve is when price is $4, individual A's consumption is 0, individual B this one, individual C this one. So this one plus this one is this one. Correct? At $3, individual A's consumption is this one, individual D's consumption is this one, individual C's consumption is this one. So summation of these three is this one. So we can get this kind of market demand curve. 2 points should be noted. The market demand curve will shift to the right as more consumers enter the market, right? So in chapter 2, we studied individual demand curve. For example, is function of price of that good, right? And price of related good and income, for example, like this, right? And market demand of good is, for example, I use uppercase like this. That is function of its own price, PJ, also income, and numbers of individuals, for example, right? So there are more consumers, demand also shift, right? That is number one. The market demand curve will shift to the right as more consumers enter the market. Number two, factors that influence demands of many consumers will also affect market demand, right? For example, its own price, its own related goods price, individuals' income, right? It's also impact on market demand curve. That is number two. Factors that influence the demand of many consumers will also affect market demand. The aggregation of individual demands into market become important in practice when market demands are built up from the demands of different demographic groups or from consumers located in different areas. So elasticity of demand. So we already studied individual elasticity, price elasticity of demand, individual price elasticity of demand, right? S equal to percentage change in individual quantity demand over like this, right? That is equal to change in Q, change in price, Q over price, like this. Similarly, market, price elasticity of demand and market, I use uppercase. For example, market elasticity demand, right? That is percentage change in large Q, market demand, percentage change in price, right? So that is change in P, change in Q, market demand, price, Q, like this. Right? That is this one. Also, we can define inelastic demand. When demand is inelastic, the quantity of demand is relatively responsive to change in price. As a result, total expenditure on the product increase and the price increase. Right? Inelastic demand curve means this one is less than 1. Right? That is less than 1. That is less than 1. That means percentage change in quantity demand smaller than percentage change in price. Okay? Elastic demand curve is this one is higher than 1. That means percentage change in QD greater than percentage change in price. Right? I'd like to use this space. Think about this. Right? Then, now think about when price, when demand is total price, when price increase, then this case, price increase, then what happens? Price increase, then quantity demand, the lower demand holds, then quantity demand decrease, right? So, and now think about, but positive percentage change in price increase, right? And percentage change in quantity demand decrease. Okay? If inelastic case, inelastic demand case, what happened? That happened, right? That kind of thing happened when price increase, right? In inelastic case, in elastic demand case, this one, right? That kind of thing happened. And now price increase. Then what happened in expenditure, right? Expenditure. Total expenditure is equal to price multiplied by Q, right? Now price increase, then quantity decrease. But we know that from here, definition of inelastic demand curve, this effect stronger than decreasing quantity demand because inelastic demand curve, right? So total expenditure increase. Total expenditure increase, right? Then what happened when price decrease? Price decrease, then quantity demand increase. But inelastic demand curve said this effect stronger than this effect. So this one increase, this one decrease, and this effect stronger than this, right? So what happened? Expenditure, this one, expenditure decrease, expenditure increase, expenditure decrease. I'm confusing. Inelastic demand curve is this case, right? So this effect stronger than this effect increase when price goes up. Price goes down, quantity effect stronger, positive. But negative, this one is stronger than this, so this one. Total expenditure on expenditure follow impact on price in the case of inelastic demand curve, right? So elastic demand curve, the opposite thing happens. Inelastic demand curve, elastic demand curve says this one. So I'm sorry, this one is, I'm confusing. Oh, correct, right? Elastic demand curve, this one stronger than this, right? So price goes up in the case of elastic demand curve. What happens? Price increase, quantity demand decrease. But quantity effect stronger than price effect. So expenditure should decrease, right? And price decrease, then this one increase. But this effect is stronger, so expenditure, this one increase. In the market demand curve is elastic, price elastic, right? So anyway, the conclusion is that impact on expenditure when price changes depends on elasticity, price elasticity of demand. So should be careful for this. So now think about isoelastic demand curve. Isoelastic demand, iso means equal, right? The meaning of iso is equal. That means elasticity is same. That means this one is equal to 1. Okay? Isoelastic demand curve says this is equal to 1. Then percentage change in quantity demand is equal to percentage change in price. In that case, what happens? Simply talking this one. Then expenditure, what happens on expenditure? Price increase, then quantity demanded. But percentage change in prices is equal to percentage change in quantity demand. So effect on income, same, right? Price decrease, quantity demand for good increase. The negative decrease in price is same effect on increasing quantity demand. So impact on income, no change. That is unit elastic demand curve. When the price elastic demand is -1 at every price, the total expenditure is constant along the demand curve. Okay? Speculative demand. Demand driven not by the direct benefit one obtains from owning or consuming a good, but instead by an expectation that the price of good will increase. Right? That is speculative demand. Think about demand for apartment in Gangnam region, for example. Right? That is typical case of speculative demand. I already explained this one. Elasticity, inelastic, unilastic, elastic. If the price increase, then what happens in expenditure? Increase, no change, decrease. If price decrease, blah, blah, blah. Okay? I already explained this. Next slide. The aggregate demand for wheat. So aggregate demand, this is some example of market demand curve. Market demand curve is summation of individual demand curve is named. Similarly, one country's aggregate demand curve is domestic demand plus export demand, foreign demand curve. Okay? So domestic demand for wheat is given by this equation. And export demand is like this. So aggregate demand is summation of to demand at the same price. Then like this. This one plus this one. So we get this one like this. So mathematical calculation of aggregate demand. So graphically, that is domestic demand, export demand, domestic demand. So when price is here to here, intercept of domestic demand, export demand here. When price at this range, total demand is just equal to domestic demand because no export demand at this price range, right? But when price is lower than here, then total demand is export demand plus domestic demand. So like this. So we can get this kind of total demand curve. That is graphical illustration. The demand for housing. There are significant differences in price and income elasticity of housing demand among subgroups of a population. Right? That is US example 2. So what happened? The price single individual group, married, head of household age less than 30, one child, married, head age 30 to 39, two or more children, married, head age more 50 or old, one child like this. Each group have different price elasticity like this. Also, this group have different income elasticity like this. For example, when we moving this group to this group, what happened? This group moving here to here, this group, price elasticity decrease and decrease and decrease, right? And when we moving here to here, income elasticity also increase and increase, right? So in recent years, the demand for housing has been partly driven by speculative demand. Speculative demand, I already explained, is driven not by direct benefit of one obtained from owning a home, but instead by an expectation that the price will increase. Okay, next slide. Example 4.5, the long-run demand for gasoline, right? Whose question is this? Would higher gasoline price reduce gasoline consumption? Gasoline price increase, then demand for gasoline decrease. This argument verified empirically using some cross-country data, right? So at this point, United States gasoline price is very low. United States consumption of gasoline is very high, right? Now think about Australia. Gasoline price is here, $4 and something, and consumption is 300. Sweden price is much expensive than United States, and demand for consumption decrease. France, Germany, UK, Norway is like this, right? Using this actual data, cross-country data, we can find projected line, fitted line like this. So we can find the negative relationship between price and consumption or demand. Okay? Next slide. Consumer surplus. What is consumer surplus? Difference between what a consumer is willing to pay for a good and the amount actually paid. Right? So what is consumers' willingness to pay? Willingness to pay is marginal utility, simply talking, in one good case. Price of a ticket is $1, price is $20, right? Then, for example, now think about X variable is here, low-cost ticket, right? Ticket and price. Price $20, then only one guy whose willingness to pay or marginal utility is $20, right? Purchase this one. Okay, this is, so consumer surplus is less than demand curve. Demand curve is marginal utility curve in partial equilibrium analysis. In general equilibrium analysis of two goods, relative demand curve is equal to MRS. Anyway, in one good case, this is a marginal utility curve. Okay? Now think of X variable is beer consumption, demand for beer, and Y variable is price of beer. Right? What is the meaning of this? If you now very thirsty, you drink first bottle of beer, your utility, your satisfaction level increased by $20. In other words, you are willing to pay first bottle of beer at $20. Okay? $20. But you can purchase first bottle of beer at $14 at supermarket. The difference between the two is consumer surplus from first drinking first bottle of beer. Okay? Now, you drink a second bottle of beer, then your happiness increase, right? Increasing your utility is amount to about $19. In other words, you are willing to purchase at $19, but market price of beer is $14. The gap between the two is consumer surplus from second bottle of beer. This process continues. And finally, you drink 6 bottles of beer. Then your happiness, your utility level increased by $40. So you are willing to purchase at $14 and market price at $14, right? So all of this one plus this one plus this one plus this one is consumer surplus. Can you understand? This explanation is easier than this. Okay, consumer surplus generalized. For the market as a whole, consumer surplus is measured by area under the demand curve, utility curve, marginal utility curve, under the demand curve, and above the line representing the purchasing price of good, market price. That is consumer surplus. Okay? So your total increase in happiness, your increase in utilities, this one plus, this one plus, this one plus, this one plus, this one like this. But actual payment of this, actual payment to purchase this beer is this one. So this one is consumer surplus. Okay? Consumer surplus measures the aggregate benefit that consumer obtain from purchasing goods in a market. When we combine consumer surplus with aggregate profit that producers obtain, we can evaluate it both a cost and benefit not only of alternative market structure, but of public policies that alter the behavior of consumers and firms in those markets. Anyway, consumer surplus is less than demand curve over market price. Right? Your increase in happiness, utility, is this one. Your total willingness to pay is this area. But actual expenditure, actual consumption spending is this one. Okay? The gap between the two is consumer surplus. Okay, that example 4.6 is a value of clean air. Value of clean air. That is application of consumer surplus problem. Although there is no actual market for clean air, people do pay more for houses where the air is clean than for comparable houses in areas with dirtier air. Value in clean air. X variable is pollution reduction, right? Pollution reduction. And Y variable is value of pollution, value of price of contamination. The yellow shaded triangle gives a consumer surplus generated when air pollution is reduced by 5 parts per 1 million of nitrogen oxide at a cost of $1,000 per part of reduced, right? Total willingness to pay is this one, but actual payment is this one. So this one is value of clean consumer surplus. The surplus is created because most consumers are willing to pay more than $1,000 for each unit reduction of nitrogen oxide, NO2, right? So I'd like to explain consumer surplus using some drinking beer example, right? Now think about, instead of one consumer, there are lots of consumers, right? And price of beer is $14, but there are lots of some 100 consumers wants to purchase beer, but these 100 guys have different marginal utility from drinking beer, right? So all the 100 guys line up based on their willingness to pay, right? So first guy is this one. One guy wants to purchase beer at $20 because purchasing and drinking, then utility level increased by $20. The guy B, willing to pay is $19, right? And $18 like this, okay? Then market price $14 and 6 guys, first 6 guys have opportunity to purchase beer at the market, right? The other guys whose willingness to pay is less than $14 cannot purchase this beer, right? In this way, we can explain consumer surplus too. Anyway, same thing. Okay, then we go network externality. Network externality, as I said before, network externality means related with some consumers' decision to purchase some goods and services, not based on utility maximization problem. So they irrational some decision of consumers. Okay. Anyway, we can find lots of network externalities in real world. Network externality, when each individual's demand depends on the purchase of other individual. A positive network externality exists if the quantity of goods demanded by a typical consumer increase in response to the growth in purchasing of other consumers. If the quantity demanded decrease, there is a negative network externality, right? So first, positive next network externalities, which is bandwagon effect. Positive network externality in which a consumer wishes to possess a good in part because others do. That is bandwagon effect. Now think about this. So demand curve is now here, right? So price is $30, demand $40. Price decrease $20, then demand is $48. So pure effect is 8. But what happened? With a positive network externality, the quantity of goods that an individual demands grows in response to the gross purchases of other individuals. Here, as the price of the product falls from $30 to $20, the bandwagon effect causes the demand for the good to shift to the right. So pure effect is this one, right? But others demand increase 40 to 48, then each individual's demand also increase. So demand curve shift to the right for D40 to D80. So total demand is 80. Okay? So movement from here to here, 40 to 48 is pure effect. Bandwagon effect is movement arising from a shift in demand curve, increase in demand because of others too, 48 to 80. That is bandwagon effect. Total effect is pure effect plus bandwagon effects. Negative network externalities. So original demand curve is this one. Okay. Now price is $30,000. So this one, demand 2. Price decreased to 15,000. Then demand is 14. So pure effect is 14 minus 2. So that is pure effect. But demand, lots of guys consume this. So some groups, some consumers do not want to consume this one anymore. So demand curve shift from here to here. Okay? D2 to D6. Then what happened? Demand decreased from here to here. So that is snap effect. Decreased by this one. So total effect, net effect is pure effect from here to here. Right? Snap effect is here to here. The gap between the two is net effect. Okay? Snap effect, negative network externality in which a consumer wishes to own an exercise, exclusive or unique food. The snap effect is a negative network externality in which the quantity of good that an individual demands falls shifts in response to the growth of purchases by other individuals. Right? I already explained this kind of thing. So we can see lots of snap effect in the real world, right? Too. So for example, choosing the name in Western culture or making name in Korea, for example, right? And 50 years ago, most popular name for girl is baby girl was, for example, 영자 and 숙자, like this. But now, lots of guys use that kind of name. So some parents do not want that kind of name for their baby. So change it slightly. For example, 영자 to 영재, right? 윤자 to 윤지, 윤재, like this. That is snap effect. Okay. That is by early 2011, Facebook is a typical example of bandwagon effect. With over 600 million users, Facebook became the world's second most visited website after Google. A stronger positive network externality was central to Facebook's success. Now think about this, like this, right? Network externalities have been crucial drivers for many modern technologies over many years. The empirical estimation of demand, right? Quantity is like this. Quantity in table format like this, right? Price, income, like this. So mathematically, we use this kind of specification. QD is equal to A minus BP plus CI. I is income, isn't it? Right? And for specific, using the data in the table and the risk scale methods, right? OLS, using risk scale methodologies, we can estimate A hat, A, B, C. Find estimate of A, B, C. That is 8.08, 0.49, 0.81, using econometric technique, right? So then we can construct this mathematically, like this. Price and quantity data can be used to determine the form of demand relationship. But the same data could describe a single demand curve D or three demand curves, D1, D2, small D1, D2, D3, right? this data, 3, this kind of thing, or 1 like this. So we don't know actually from data. The form of the demand relations, the price elasticity, now I'd like to use whiteboard. Right? Now think about Q equal A minus BP, right? That A and B is constant number, and Q and price is a variable, isn't it? From here, we can calculate changing rate of Q over changing price. That is minus B, isn't it? Right? For example, y equal ax plus b, then first derivative of y with respect to b. More exactly, instantaneous changing rate is simply a like this, right? So using same formula of forced differentiation we know, so more specifically instantaneous changing rate, right? Or changing rate is like this. And we know price elasticity of demand. Price elasticity of demand is changing Q over changing price multiplied by Q over P, right? So this one is minus B, so minus B PQ like this, right? That is explained here. But usually economists use logarithm, right? Instead of this Q equal A minus BP. So we use, economists usually use demand curve as a logarithm. That is, this one is equal to A minus B log price, natural log, for example, and C log income, right? Why we use logarithm instead of this? It's very simple, right? Think about changing log Q, changing price, partial derivative of log Q over with respect to price is simply minus B, right? That is minus B. That is Y variable, that is X variable, that is Z variable, for example. Then we know this. Why we use then, that is log price, right? Because this one is equal to percentage change in Q over percentage change in price, right? This one is change in Q, change in price over Q, like this, right? If we use logarithm when estimating demand curve, then B is just price elasticity of demand. That is minus B. Minus B is just price elasticity of demand, right? Then C is equal to, what is C? Partial derivative of Q with respect to income, log income, right? That is equal to percentage change in Q, D, over percentage change in income. That is, right? Income elasticity of demand, isn't it? Because of this, economists usually use logarithm instead of this kind of specification. Can you understand? So that is a little mathematics, right? So simply talking, in high school math, you start the log y, log x, right? Is equal to, what is this? This one is equal to change in y over y, change in x over x, right? Simply talking change in y over change in x, x over y, isn't it? So same thing. I use log q instead of log y, log price instead of log x. So this one is just price elasticity of demand, and this one is just income elasticity of demand. Because of this, we use logarithm specification, right? When B2, also this function, some use this kind of thing. B1 plus B2 log price of other good, right? Relating good plus C log income, okay? That is specification of this kind of function. Quantitative demand, market demand is function of its own price, and related goods and income. Okay? Mathematically specified like this. Then we know this one is price elasticity of demand, the fit projected value of B2, right? B2 is price elasticity, cross price elasticity of demand, right? And C is income elasticity of demand. I'm sorry, large uppercase of D, right? So when B2, the cross price elasticity is positive, the two goods are substitutes. That is the definition of substitutes. This one is positive, then good I and good J is substitutes with each other, right? When B2 is negative, the two goods are complements. That is definition of substitution and complements. That is example of this one. Think about this kind of function. So some complicated setup for this, right? The acquisition shredded with cereals of Nabisco, right? Nabisco produce, okay. Nabisco produce shredded wheat, right? And post, right? Produce grape nuts. And two goods are substitutes, right? And from post merges Nabisco's, right? And two goods. So post wants to merge Nabisco, right? That is the situation. Then what happened? The acquisition of shredded wheat cereals of Nabisco by post cereals raised the question of whether post would raise the price of grape nuts or price of Nabisco's shredded wheat spoon size. One important issue was whether the two brands were close substitutes for one another. If so, it would be more profitable for Post to increase the price of grape nut after rather than before the acquisition, because lost sales from consumers who switched away from grape nuts would be recovered to the extent that they switched to the substituting good. To solve this kind of problem, right? So demand for grape nuts is function of A minus B log price of grape nuts plus log I plus like this, right? And estimate, so sort of this kind of equation estimated usual data. And we find that this one, right? This one, that is shredded grape nuts. That is grape nuts price. And this Nabisco's what? Shredded wheat, right? And we calculated this one, cross price list of demand. That was 0.14. So we know the positive, so complements. But this is not so strong substituting relations, right? So the demand for grape nut is elastic with the price elasticity above minus the income elasticity 0.62. the cross price elasticity is only 0.14. The two series are not very close substitutes. Because of this, not so strong incentive, increase price of grapes nut before acquisition. Okay? Okay, so section 4.6, so skip. And we go this one, mathematical, some question for this. How can I say? Okay. That is a candidate subjective question from first exam. Okay, I'd like to use those. Right? So utility function. We know that utility function is Cobb-Douglas style. C1 alpha. There are two good, demand for two good, C1 alpha and 1 minus alpha. So alpha plus beta, right? Or we can say that this is beta, right? In some cases. Anyway, like this. So, so utility maximization problem is this one, right? Subject to budget constraint. Budget constraint is equal to, everybody know that P1, C1 plus P2, C2 is equal to income, right? And from here, anyway, we started to we found optimal consumption bundles of two C1 star and C2 star under the condition that MRS is equal to slope of budget constraint, right? So using this one, we can derive demand, that is demand for good 1, and that is demand for good 2. We can calculate demand for good 1 and demand for good 2 mathematically when utility function is like this. Okay? So that is appendix, our appendix, right? So how to solve this one? So usually we solve this kind of thing using Lagrangian multipliers function like this, right? So that is some way to calculate, find some solution of this optimization problem. There are two variables, basically, right? C1, C2 star is two variables, and that is not equation. Anyway, there are some equations, right? Relations. So how to solve this one mathematically, right? That is a very important thing. So to solve this one maximization problem with constraint, we use Lagrangian function, Lagrangian multiplier methodology. That is this one. First, we construct Lagrangian function. For example, pi is equal to like this. C1 alpha, C2 alpha, 1 minus alpha, this one here, right? Plus, we use lambda, right? Some artificial endogenous variable, lambda, and I minus P1, C1 minus P2, C2 then, right? I minus P1, P2, or minus lambda, P1, C1 plus P2, C2 minus income, right? The same thing. Okay? So first step is construct this Lagrangian function. In this Lagrangian function, there are three endogenous variables. C1, what is this? I'm sorry. C1, C2, and lambda, three variables. To solve this kind of thing, we require three equations. We got three equations from first derivative of this Lagrangian function with respect to three endogenous variables C1, C2, C3. Right? So for three first order condition is like this. Right? Partial derivative of this function with respect to endogenous variable C1 should be equal to 0. Right? And second one is partial derivative of Lagrangian function with respect to demand for good 2. This one should be equal to 0. Right? The final first order condition is partial derivative of Lagrangian with respect to lambda. Right? Should be equal to 0. Can you understand? Right? Then you can calculate this one. Partial derivative means only C1 is variable and C2 and lambda are considered as fixed value, constant numbers. Okay? Then partial derivative of Lagrangian with respect to consumption of demand for good 1 is equal to, this is variable. So what happens? This one is equal to, that is just considered like constant numbers. And this one, first derivative of this one is alpha C1 alpha minus 1. Right? And this is constant number, only C1 is variable in this case. So plus lambda multiplied by this one disappeared, only minus P1 left. Right? This one should be equal to 0. Partial derivative of this one with respect to C1, this is only one variable. So this one left. Right? So that is constant number. So partial derivative of lambda P2 C2 with respect to C1 is equal to 0. Similarly, lambda I, partial derivative of lambda I with respect to C1 should be equal to 0. Only this one left. Right? Rewriting this one is minus lambda P1 is equal to 0. Okay? So now this one. Partial derivative of Lagrangian function with respect to C2. That is equal to, this is endogenous variable, but that is constant number. So C1 alpha, C2 1 minus alpha minus 1 alpha. 1 minus alpha, I'm sorry. 1 minus alpha, isn't it? Right? This one is equal to minus alpha. Right? Also, this one is minus lambda P2 is equal to 0. Right? And third condition is constant disappeared and only this one left. This is a variable. So I minus P1 C1 minus P2 C2 is equal to 0. We can construct three first order conditions. Right? So now we have three equations, 1, 2, 3, and three variables, C1, C2, lambda, right? So three equations, three variables, endogenous variables. So we can solve this simultaneous equation, and we can calculate the demand for good on C1 star, C2 star, C3, C2 star. So mathematically, can you understand? So rewriting this, right? This one, rewriting this, what is this? This one we can write this, alpha C1 alpha minus 1 C1 C1, right? Here, multiplied by C1 divided by C1 and C2 1 minus alpha minus lambda P1. Okay? So C1 alpha minus 1 multiplied by C1 means plus 1. So C1 alpha left. Right? C1 alpha left. And we know C1 alpha, C2 1 minus alpha is U, total utility. So this one is like this. Right? Minus lambda P1 is equal to 0. Can you understand? So from here, this one is equal to 0. So alpha U over C1 should be equal to lambda P1. So from here, P1, C1, P1, C1 is equal to alpha U over lambda, isn't it? Right? And from here, rearranging this, C2 multiplied by here and divided by at the same time. Right? Then we can get this one is equal to 1 minus alpha U, 1 minus alpha U, C2 is equal to lambda P2. Right? So, rearranging this P2, C2 is equal to 1 minus alpha U over lambda. This one and this one is inserted here. Then what happens? Income. So, income is equal to this one, right? Then income is P1, C1 is alpha U over lambda plus P2, C2 is equal to 1 minus alpha U over lambda. Right? This one is alpha plus 1 minus alpha. So, just like this. Right? So, like this. So, I'd like to use that space again, right? Anyway, from here, we know that lambda is equal to U over I, right? Lambda is equal to U over I. Okay, I'd like to stop here and we go the other side of whiteboard. Okay, it's okay now? In the earlier first order condition, right, I said P1, C1, first order condition was P1, C1 was equal to, P1, C1 is equal to alpha U over lambda, isn't it? Right? From at the side, I said P1, first order condition, first one or first order condition is this one. Second one is P2, C2 is equal to 1 minus alpha U over lambda. And finally, I said lambda is equal to U over I. That means, right? So this one inserting here and here, right? First this one. Then P1, C1 is equal to alpha U divided by U over I, isn't it? Then U disappeared, right? And that is alpha I. In other words, C1 star, optimal demand for good 1, is equal to alpha I over P1. That is optimal demand for good 1, right? Solution of utility maximization problem when utility function is Cobb-Douglas format. Similarly, we know that P2C2 is equal to P2C2 is equal to 1 minus alpha U and lambda is equal to U over I. So rearranging this, we can get C2 star is P2 1 minus alpha I, right? So demand for good 1 is I, income, alpha, I, coefficient, income, and price. Everything is constant number. So we calculate the C1, C2 star like this. That is demand, right? Optimal demand for good 1 and good 2. Right? Solution of utility maximization problem when utility function is Cobb-Douglas. Okay? So we can derive demand curve, demand for good 1 like this, demand for good 2 like this. right? And that is this one. And a slight different version is of solutions like this. So as I said before, economists usually use logarithm specification rather than variable function. So for example, utility function is maximization of utility, right? Is what can I say? C1 utility function is log, right? C1 alpha, C2 1 minus alpha, right? Subject to price. I equal P1 C1 plus P2 C2 like this, right? Then this function, rewriting this function, utility, log utility, right? Log utility is log C1 alpha plus log C2 1 minus alpha. Or this one is alpha log C1 plus 1 minus alpha log C2. Okay? Then we can construct a Lagrangian function like this. Pi is equal to alpha log C1 plus 1 minus alpha log C2. That is objective function. And now constraint plus after adding this artificial endogenous variable lambda is I minus P1 C1 minus P2 C2. Right? So first, then step 2, construct Lagrangian function with log format like this. Then we can find three partial derivative condition, 3 first order condition, right? Round pi over log C1, right? C1. Then that is equal to alpha over C1. First derivative of C1 over Lagrangian function is like this, right? And this one disappears and minus lambda P1 left. This one is equal to 0. Second one is C2 is 1 minus alpha C2 minus lambda P2 is equal to 0. Right? And third equation like this. Third equation is I minus P1 C1 minus P2 C2 is equal to 0. Right? So from here we know that this one is equal to this one. So then P1 C1 from here P1 C1 is equal to alpha over lambda, isn't it? Right? And similarly from here we can get P2 C2 is equal to 1 minus alpha lambda. And this one inserted here, then I minus alpha over lambda minus 1 minus alpha lambda should be equal to 0. I'd like to use that space again. Okay, where is marker? So there, so I minus alpha lambda minus 1 minus alpha lambda should be equal to 0, right? So that means I minus lambda alpha plus 1 minus alpha is equal to 0. So this alpha plus 1 minus alpha is 1. Right? This one is simply 1. Right? So lambda is equal to 1 over I. Right? And there we know that P1, C1 was equal to alpha I. P2, C2 is equal to 1 minus alpha I. That is first order, constructed from first order condition, right? So this one inserted here, this one, then what happens? P1, C1 is equal to what I'm talking about. C1, okay, directly. Anyway, this one is not so important to solve this one. Right from here, C1 star is equal to alpha I over P1. Right? Demand for good one is specified as some constant numbers alpha I P1, price of good one. So solved. Right? From here, C2 star is equal to 1 minus alpha I P2. So we can calculate demand for good 1 and demand for good 2, or a solution of utility maximization with respect to budget constraint when utility function is Cobb-Douglas format. The conclusion is this one. Right? So this is end of some chapter 4. Thank you very much.